Okay, I'm going to do a quick video, maybe not so quick, on copying a triangle. And the construction instructions tell you to refer to page 235. And again, you're attempting to do this on GeoGebra as if all you had was a compass and straight edge available to you, like you were doing it on paper. So the first thing I'll remind you to do is we don't need to see the axes. And the instructions I give you say go ahead and just make a triangle. So go to the polygon tool and use 3 points to construct your triangle. I'm just going to make things a little neater and show the vertices again, capital A, capital B, capital C. And notice that the side opposite capital B is a lowercase b, and the side opposite capital C is a lowercase c. We can identify the lengths of those segments with lowercase variables. So I want to copy this triangle, but again, suppose I only had a compass and a straight edge. So I'm going to use my straight edge to first draw a line. And I'm going to unclick E, and you'll see why in a minute. I'll leave D right there. And I don't necessarily need to see F. So it can be helpful to, along the way, undo labels so you can really see what you're doing. So what I want to do is I want to create a segment here from D that's the same length as BC. So if I had a compass, I would measure from B to C. Now we already know that's A, and then I would come down here and draw that arc, and you can see that illustration on page 235. So what I'm going to do up here is I'm going to do a circle with a center and a particular radius. So there's my center. And what do I want my radius to be? I want my radius to be A. So if I then locate this intersection right there, DF should have the same length as BC, correct? Because I drew this circle, I took my compass and measured this distance, which was A, and transferred it to here. We could double check that. I could use the measure tool, distance or length, and I could measure DF, and it tells me it's 6.7, and up here it tells me that A is 6.7. So I'm just going to undo that. Okay, so DF is congruent to BC. Well, how am I going to locate this point A down here? Well, think about it. If I draw a circle around B that has a radius of C, and I draw a circle around C that has a radius of B, they will meet at point A. So I want to do the same thing down here at D. So I'm actually going to, now that I'm done with this circle, I don't want to see it anymore. So I'm going to create a new circle around D that has a radius of C. So I'll go to my circle tool, circle with center and radius. I want it to have a center of D, and I want it to have a radius of C. And then I want to draw a circle around F that has a radius of B. And where these two meet should be the same thing as where they would meet on the triangle ABC. So let's get that point of intersection right there. And then I don't need to see my circles. And I think I will create a segment between D and F so then I don't have to look at that line. I maybe should have done that before. So let's create segment DF. And I don't need to see that it's H. Ugh. And then I can undo line F. Do you remember where that was? Line F. We don't need to see that. And now I can do, you can do segments, or you can go back now and do a polygon actually. D, G, whoops, polygon. D, G, F. Up and then back to D. There we go. And I don't want to see those labels. And I'd bring down my text box. Oops. Text. And I would say triangle. Do we have one of those right there? Triangle GDF is congruent to triangle ABC. Make sure you get them in the right order. GDF ABC. Beautiful. And that is by SSS. And again, although you can see 6.7, 6.7, 6.38, 6.38, 3.04, 3.04. Voila. Oops. If you put a name, a date, and a title, that'll make it even better.